the massive industrial complex at Derby, a sprawling testament to British engineering, dedicated entirely to the production of the Merlin engine.
Dimensions are within tolerance. Apply the certification stamp.
Move this pallet to the foundry immediately. We are behind schedule.
We need 3 lengths of the chromoly stack.
Inventory updated. Heading to the foundry. Okay, easy now. Keep the tilt steady. Got it. Flow is clear. Move to the next one. We check every surface for defects like these. Then it's off to the X-ray room to ensure there are no internal inclusions before final approval.
From the furnace glow at 515 degrees to the rapid quench and subsequent aging, precise timing is critical for optimal strength.
We need the cylinder heads weighed and inspected immediately. Roger that. We'll prioritize the high volume lot.
The sequence begins with face milling the gasket surface. Then multi-axis centers precisely shape the combustion chambers and valve seats.
A specialized crankshaft grinding facility. The crankshaft rotates slowly as the grinding wheel contacts the journal surface.
The vibration amplitude is still too high at operational speed.
We need to adjust the correction points on the second plane.
Rigs. From glowing billets to finished sets, this line transforms raw steel into precision connecting rods.
Through controlled forging and subsequent heat treatment, the aluminum achieves T6 temper, providing the high strength required for aircraft engines.
Beginning as bar stock, the valves are upset forged and heat treated. Precision machining grinds the stems to
The CMM verifies the precise lobe profiles against specifications, ensuring critical valve timing accuracy for optimal engine performance.
Precision machining operations, first showing hub facing and boring, then 5-axis machining, refining vane profiles.
Precision machining ensures optimal airflow to all 12 cylinders. Then, submerged in The meticulous calibration process ensures each carburetor delivers the optimal air-fuel mixture, critical for Next, we use the spring compression tools to install the split keepers, ensuring they lock the spring retainer securely.
With the crankshaft now in place, the main bearing caps are secured. The team then meticulously torques the bolts to the precise specifications.
This precise tightening sequence, working from the center outward, ensures even clamping pressure and prevents gasket distortion.
The push rods connect the lifters to the rocker arms. After securing the supports, the valve lash is precise.
Okay, rotating the engine slowly by hand. Check the timing marks.
Still aligned perfectly, no piston contact.
Backlash is good.
The two-stage supercharger, critical for high-altitude performance, is carefully lowered. Precision is key as the mounting.
The intake manifold is aligned with the cylinder heads, followed by the systematic torquing of the bolts.
Ensure the wire routing matches the firing order diagram exactly.
Checked. All connections are secure and continuity tests positive.
The heavy reduction gear assembly is hoisted and aligned with the crankcase using dowel pins.
Make sure that's torqued to the specs. Already done. I'm applying the safety wire now. Watch the clearance on the exhaust manifold here.
We use the specified standoffs, should be fine. We can run the continuity check now.
Valve lash confirmed, rotation is smooth, oil levels are good.
Checklist synchronized. Engine 52 approved for test cell.
Is the dynamometer aligned?
Yes, sir. Coupling confirmed.
Coolant systems primed and ready. Confirming ignition sequence is complete. Idle speed steady at 800 RPM.
Pressure looks nominal. Begin the first run-in stage now.
We are at maximum continuous power. Engaging high supercharger now. Check the boost pressure.
Check the serials against the manifest. We need these moving now.
Aye, fully inspected. Taking her away.
Easy now, watch the clearance. A little to the left. All right, she's seated. Start the bolts.
The spectrometer confirms the alloy composition matches the specifications.
Excellent. Log the results and proceed with the hardness tests.
Highly skilled toolmakers operate precision machines, creating the specialized cutting tools and gauges essential for consistent quality. Preventive maintenance is crucial to supporting continuous Merlin production. Our technicians ensure every component meets the original accuracy specifications. Watch the cutting tool carefully. Maintain steady pressure to ensure a precise cut.
The new two-stage supercharger configuration improves high-altitude performance significantly.
What are the projected boost pressures for the Mark 60 series?
Preserving the story of how British engineering contributed decisively to Allied victory. These
Badge and papers, quickly now.
Luftwaffe incoming! Everyone to the shelters!
Keep the line moving, steady on.
Pass the salt, would you?
Did you see the production numbers? We're ahead of schedule again.
Good. Let's hope it brings the lads home sooner.
A historical comparison showing parallel Merlin production in Britain and the United States, utilizing both batch and mass production methods.
Cell 4, increase throttle to 2500 RPM.
Roger that, applying power now. We have a red line on oil pressure in cell 7.
Gone. Despite the devastation, the response was immediate. Within weeks, the collapsed sections were rebuilt. In the vital...
We may allow our sleep. The German war is therefore at an end. We have achieved victory in...
Watch the clearance on that starboard mount.
Easy now, she's almost home.
Get the bolts ready.
The combination of the wooden fuselage and the twin-stage supercharged Merlins gave the Mosquito its legendary performance. With its two-stage supercharged Merlin engine, the Spitfire Mark X finally matched the Luftwaffe, becoming the most crucial variant of the war.
The installation of the Packard Merlin V1650 was revolutionary. It transformed the Mustang from a mediocre aircraft.
The naval Merlin variants required extensive adaptation, utilizing corrosion-resistant primers to protect against the harsh marine environment. From the heart of Rolls-Royce Derby, the Merlin engines began their perilous journey across Britain, a vital supply chain fueling the war effort.
She held up beautifully through the dive. Remarkable engine.
Check the oil pressure now. We need her ready in 5.
The sustained offensive required continuous reliability. Merlin-powered Lancasters delivered the majority of the bomb tonnage dropped on Germany.
The intelligence gathered by these lonely missions proved critical, guiding both bomber targeting and invasion planning. Starting at 1,000 horsepower, the Merlin's continuous development saw the introduction of the two-stage supercharger.
You see the complexity here on the 605's variable geometry supercharger.
Yes, quite different from the Merlin's simpler two-speed design.
Post-war Merlin applications showing the engine's continued service after 1945, with civilian aircraft conversions and
as men were conscripted, women stepped into skilled roles previously denied to them, demonstrating expertise that rivaled their male counterparts.
We must ensure the Merlin project receives top priority for aluminum stock.
The civilian sector will have to manage the shortage, sir.
The connecting rod fractures are clearly due to stress fatigue.
This new design with the strengthened alloy resolves the issue completely. This global production network multiplied Merlin availability far beyond what Britain alone could produce, a testament to Commonwealth cooperation.
This massive investment, totaling billions of pounds, saw the cost per engine decline sharply, demonstrating unparalleled.
Reliability engineering ensured the Merlin's dependability, analyzing failure data to identify critical trends and continuously improve the design. Prioritizing output over safety, these brave men and women endured incredible hazards, knowing their work was essential to victory.
The Merlin engine, a symbol of British industrial might.
We know that every rivet we set helps bring our lads home.
The damage at the plant is severe, but we can divert capacity.
And the bottleneck's in Sector 4. We need those engines now, gentlemen. The pilots are waiting.
The Merlin engine wasn't just a technical marvel, it was absolutely central to the Allied victory. Its reliability and continuous improvement were unmatched.
This successful Anglo-American collaboration ultimately produced over 223,000.
The comparison charts highlight the improvements. The Merlin XX produced 1,080 horsepower, a significant.
The revolutionary 60 series engines featured two-stage supercharging. This complex system, with
All right, lads, easy now. Watch the starboard mount. Coming down slowly, Sarge. Clear on the port side.
This comprehensive overhaul system was essential, allowing the RAF to sustain a larger operational fleet by repeatedly rebuilding engines.
Despite the harsh conditions, the Merlin engines provided critical air cover. All right, clear prop.
Starting sequence initiated.
The cloud cover was thick, but the PRU got through.
Look here.
That confirms the V-weapon assembly is operational. Send this to command immediately.
The sound of that Merlin engine was the most beautiful music I ever heard. We knew then we were saved.
The fatigue crack initiated right here at the fillet radius. We need to redesign for a larger radius to distribute the stress more evenly.
Heat on cylinder banks 1 through 4.
Hot oil circulating now, sir.
Prepare for 20 degrees of blade travel. Clear prop. Contact U-boat bearing 045.
Diving. Engaging target.
Depth charges away.
Too much boost, pull it back now. Monitor the temperature.
Right, this casing needs a full inspection before we seal her up.
The Merlin's distinctive sound becoming iconic, representing an entire era, and providing an emotional connection to historical events.
Transport operations emphasized reliability and endurance. The Merlin engines, though adapted from combat roles, provided the critical logistics support needed.
These specialized modifications, from experimental 3-speed superchargers to high-altitude optimization, redefine the limits of the Merlin engine.
It's a relentless pursuit of speed.
They've increased the boost pressure so much that reliability is measured in hours, not years.
Adapted from the legendary Spitfire, the Rolls-Royce Merlin V12 powered these unlimited hydroplanes.
The Merlin engine didn't just win the war, it taught us how to build the future. Here, we ensure its lessons are never lost.
The Merlin's 2-speed, 2-stage supercharger is what gave the Spitfire its high-altitude advantage. It's a marvel of fluid dynamics.
Specialized restoration operations maintaining authentic Merlin engines requires expert assessment and meticulous documentation.
When we measure this casing against the schematics, the dimensions are slightly off, and crucially, these aren't period-correct machining.
From salvaged originals to modern reproductions made possible by reverse engineering and CNC machining.
Step inside the legendary Merlin engine. From the 1940s production line to virtual assembly,
When I look at this old photo, I remember the lads we lost.
Good men.
We built these engines for them, you see. We had to.
In what way? We must consider the resource allocation.
The Griffin program suffered because of the Merlin's priority.
I disagree.
This comprehensive comparison demonstrates the Merlin stood among the best, balancing performance, reliability, and... But what if the engineers had pursued the 3-stage supercharger? This road not taken promised significant power increase.
Our modern analysis validates the brilliance of the Merlin design, showcasing its excellence given the technology of its era.
History is not fixed. The Merlin's significance has been continuously reinterpreted.
Today, we remember the sacrifices made 75 years ago, ensuring the legacy of the few endures.
We lost a lot of good men, but we built the best engines in the world. We did our part.
Precise environmental control is essential. By maintaining stable temperature and humidity, we prevent...
By comparing the different variants, visitors gain a deeper understanding of the Merlin's operational conditions and its historical impact.
By sharing our technical schematics globally, we were able to complete the Spitfire restoration ahead of schedule.
The pre-flight inspection is complete. No anomalies noted on the airframe.
Good. The engine run showed stable temps. Logbook signed off.
The certification for these modifications seems complete, but we need to verify the life-limited parts.
We addressed that under the EASA standards, not the FAA.
The harmonization of these standards is crucial for maintaining the integrity of the heritage fleet.
Absolutely. The equivalency...
This comparison between the historical empirical data and our modern computational approach validates the model's accuracy.
The Merlin engine's wartime production prioritized output above all else. This led to significant environmental...
And this right here, kids, this is what won the Battle of Britain. Isn't she magnificent?
We knew the risks. When the Luftwaffe came, we kept working. But Arthur, he was next to me, gone in an instant.
The success of the Merlin engine depended not just on famous designers, but on thousands of unsung heroes.
Their approach to systematic improvement is key.
But how do we apply that to additive manufacturing?
It informs our design philosophy.
No. The Merlin story teaches that greatness emerges from sustained effort, continuous improvement, and collaboration.